Thanks ever so much. I'm going to talk about measuring ecological resilience, but you'll notice in my title of my talk, I use the words degradation and recovery. And that's partly because, mostly because, I like those words much better than ecological resilience. I have, maybe just it's a fundamental problem of trying to understand what resilience really means, so I've translated them to talk about degradation and recovery. So these are two definitions of, two parts of a definition for ecological resilience that folks have put these kinds of definitions up already today. They're really both parts of the same sort of question, and if you stood back, you could say, you know, I see how they fit together and they're not really contradicting each other. Well, however, there is some subtle differences that make me uneasy. In the first one, it's about embracing change, and it may or may not have a natural component to it. Depends on which author you're looking at. The second one is much more about things returning closer to natural, or it's a return back, a recovery to natural. I'm going to talk, if I can figure out where the button is. I'm going to spend most of my time here, I think, unless you're willing to say this top one is also about natural. I think resilience is all about how do we get systems to, when they're disturbed, to move back towards natural. And that isn't the terminology that's used in all of the literature. But if we could make the top one also about natural systems, then I would say I'd be talking about both. There is lots and lots of opinion about how to measure or how resilient different ecological systems are. What we don't know very well, though, like this, is how to actually measure it, or we don't have good measurements of the system. I'm going to use an example from the Alberta Biodiversity Monitoring Institute, so data that's collected by the ABMI to show how one could actually evaluate resilience, how you could monitor resilience or recovery or degradation of a system. What it is almost like a test of whether our knowledge, our opinion, is real. I'll also stress, I'm going to go a bit of a divergent, I'm going to talk about resilience or degradation and recovery at two scales. One, a landscape scale, and secondly, at a site level. We spent most of the morning talking about recovery at a site. From a landscape perspective, much of what we do in that landscape, some of the things we do in that landscape, we don't ever expect to recover. When we put a road in, we expect that road to stay there forever. When we put an agricultural field in, we expect that agricultural field to be there forever. So systems at a landscape scale were less interested in recovery and more interested in measuring degradation. That's part of resilience, but it's a different flip side, if you wish, of resilience. At the landscape scale, we're interested in how far can we push the system and still maintain a more or less natural system, or at least the components of a natural system. At a site level, there are things that we do, we expect to reclaim them, and we expect those to recover. So the different scales are really asking different questions. I'll try to get into both of those. I'm going to use information from the ABMI. One could do the same sort of thing with information from other programs. I use it because I'm very familiar with the ABMI. I work as part of the Biodiversity Monitoring Institute. And it has some really neat data that can be used to answer, to set up how you would monitor, how you would measure resilience, how you would measure recovery of a system, and how you would measure degradation in a system. I'll spend 2 or 3 minutes just going through the ABMI. Many of you in the room probably know about it, and I'll refresh your memory, and those who don't, it's a bit of a crash course. So the ABMI is a series of points throughout Alberta. There's 1,600 or so of these. The goal is to visit 1/5 of those points every year, so after 5 years we've sampled all of the points. And the goal of the program is to be able to detect a change in ecological condition if such a change occurs, and the goal is a 30% change. So if there's a 30% change, the program would be able to detect it. In addition to the on-grid sites, there's a whole bunch of off-grid sites, we call them, and that's to do modeling, to develop the relationships that one can use to assess and predict change. The critters that are included in the ABMI, there's a broad diversity, plants, animals, but mosses and lichens and bugs as well. So there's a variety of critters. The goal was to get relatively few groups, but many, many, many critters, so regardless of the change in the environment, we would be able to detect it if there was a change that occurred. There's things like birds that are measured on a fairly broad scale. It's 300 meters between point counts. Mammals is a long linear transect where there's snow tracking done. A bunch of the biota that don't move around are measured in a smaller pattern. You'll notice that this central point is the same for every sampling technique, but the scale of the sampling is what's appropriate for that particular critter. In addition to measuring critters, measure characteristics of the habitat as well. Again, centered on the same site. At each of the 1,656 sites, then, the ABMI also monitors the nearest wetland. So if that's the site, find the nearest wetland and monitor characteristics in the wetland, things like vegetation and aquatic invertebrates, plus the physical chemical characteristics of those wetlands. In addition to measuring things on the ground, then there's also some air photos, satellite imagery sorts of things. So evaluate the characteristics of disturbance at and near the sites, and the characteristics are both human disturbance and vegetation characteristics. So, a series of points, satellite images, remote sensing around the point, on the ground sampling for a whole variety of different things. This is where we were at the end of last year, so think 2 or 3 months ago. Approximately 800 sites sampled throughout Alberta. The blue points was a pilot, so we didn't sample everything at the blue points. At the red points has expanded to sampling the whole, the complete of the things that were included in the ABMI. But there's a good range of samples throughout all of Alberta, plus approximately 125 off-grid sites to build these relationships. We take the information and then use that information to talk about the status at the regional level. So think of this as degradation at a regional scale. So for any critter, think palm warbler, talk about what proportion of the sites it's at and what is the abundance where it is present. That's used to talk about the status of the warbler, and that warbler plus a bunch of other talks about the status of long-distance migrants or the status of birds or of forest birds or birds. And then you can just add all the other stuff in together to talk about the status of biodiversity. So it's just an information pyramid. The status of any given critter is simply based on the points that we sample. These are all real sites. From those sites, we can determine what is the expected numbers of the critter when there is 0 human footprint, the natural conditions, if you wish. Then if you sample a region of interest, let's say it's the oil sands region, you can get an estimate of what is the observed number of the critter in the region, and the status is observed over expected times 100. A fairly simple concept. The math involved with this isn't quite so simple, but the concept is quite simple. So this would then talk about degradation of palm warbler in the area of interest. You can do exactly the same thing for every other critter. This is a map of birds. That line in the center is reference conditions. They are exactly as expected under reference. If they're below, it means they are less abundant than reference. If they're above, it means they're more abundant than reference. Both of those is a degradation of the system. We can do it with birds, plants, habitats. You can treat it in exactly the same way. Because it's on a common scale, you can get an overall average. This report was produced in 2010, I think. And at that stage, the average for the oil for the lower Athabasca region was 94. Obviously, it isn't 94 intact everywhere. The average of the region, yes, it has, on average, an intactness. But one can use exactly the same modeling to predict what is the expected intactness at a pixel level throughout there. And there's variation exactly as we'd expect. So you can use this information collected over a broad area to talk about degradation at the regional level. And we know there's going to be degradation. To me, that is part of resilience. And we've done the same sort of thing for a variety of other regions. You can also use the information to talk about recovery of ecological characteristics at a particular site. And this gets back to some of the stuff that Suzanne talked about. I mean, we're using slightly different methods, but it's the same thing. It is how similar is the biotic community in a disturbed site to the biotic community in a reference site. In this case, it is a natural site. This is the same information that was used to calculate intactness at the regional scale. Each of these little points is a point that is sampled. The white dots are simply the biotic communities in sites that have very low human disturbance. In Alberta, we don't have many sites that have no disturbance, but we have quite a bunch that have very low. So you can take the information and calculate what is the biotic community in undisturbed site and place that on a scale then that says how similar is each of these sites to the average community in an undisturbed site. You can also then plot the information on a scale of human disturbance. So at the site was there very low human disturbance up to very high human disturbance. If one just looks at communities where the vegetation has been removed, think forestry, cut blocks. As we get to 100% of the vegetation removed at the site, the degradation is about 50% in the biotic community. If we disturb both the vegetation and the soils, think agriculture, the degradation in biotic community goes down to about 30%. Totally makes sense, which is good because you'd like things that make sense. But this then allows you to talk about a situation where we said, can we use this information to talk about biotic recovery? This is the same set of points I talked about before. Arranged on amount of human disturbance, deviation in biota from undisturbed condition. And you can create this line then that says, on average, we expect the deviation to go down like that as the amount of disturbance in the area goes up. What's neat is then you can sample your points of interest. So we did that. We worked with some folks at Alpac and said, we're interested, or they were interested, in cut blocks 15 years after harvest. Well, at harvest, they are 100%, 90 to 100% disturbed. You expect them to be on the line about there. 15 years later, they are above the line. What it means is those cut blocks are recovering the biota that you'd expect in those sorts of habitats. And it's simply using ABMI to create this line, and from that, evaluating your particular point, whether it's a cut block or a well site or a mine site. How much has it recovered after it's been reclaimed? In the case of cut blocks, there wasn't any reclamation, but there still is recovery. That is a real example, a hypothetical example. And I just put this in when I was listening to talks this morning. So I wasn't going to show this because this is hypothetical. I made it up, okay, guys? This is something that we're using to try and develop a project. But it may be closer to what folks in the room are thinking about today, so I just put it in. We can use the ABMI information to describe what as the community you'd expect in undisturbed conditions, or relatively undisturbed conditions. That's natural variability and measurement error. And I would stress measurement error probably is most of that variation. Measuring an ecological system is hard. You take then a site that you think you're going to disturb, you expect it to start in that undisturbed condition. This is hypothetical, I made it up. So you expect it to start there. After it's been disturbed, you expect it to be much lower. By creating these white dots, though, you've created the scale of which you can measure ecological degradation, and then over time, as you reclaim the site, you can measure what is the jump you gained by reclaiming the site, and over time, over time, did that site march back towards recovery? This is hypothetical. All we have at present is these white dots. You have to actually go and sample the rest to produce the rest of this figure. But there's no reason you can't do this. And you can, this is an example with ABMI data. You can do it with other data too. So I'm just going to end then with a bit of an integration between the two scales. By having data that works at both scales and measuring things similarly at both scales, you can talk about both degradation at the regional scale, at a landscape scale, and recovery at a site scale, and you expect the two to interact. So as you recover areas, as you reclaim areas, you expect the regional degradation to be less. Just because you expect it doesn't mean it's true. This allows you to test whether the expectation actually is realized. I think it's quite powerful. So I think there is really strong value in integration among scales. I'm going to end with a few take-home messages, and I made these up. So they're my thoughts, relatively quick thoughts. So I may change my mind later on. I'm not a big fan of ecological resilience, but as long as folks are willing to talk about natural systems, I think we can talk about recovery of sites, and I think at a regional scale we can talk about resistance to degradation, which is part of resilience. So maybe I'm not as big a skeptic as you might think, as I say I am. One can do things with site recovery, but you need lots and lots and lots of natural sites. Without the background of points here, the information in those few points is much less meaningful. And finally, we can talk about ecological degradation at the regional scale if we collect the appropriate regional level information. And they fit together really well. Thank you.